Welcome back to the Deep Dive. Today we're digging into a really interesting bit of source material. It's an excerpt from a metabolic education video. And we're zooming in on, well, the forgotten macro, amino acids. So if the body must deal with this excess nitrogen right away to protect the brain, what's the specific solution? What's the mechanism the source material points to?
That specific mechanism is the urea cycle. It's this essential, non-negotiable pathway. Its whole job is basically to trap that toxic ammonia and convert it into urea, which is much safer, and that can be passed out through the urine. It's a critical pathway. No bypass allowed.
That's amazing, isn't it? That the body dedicates an entire, like a metabolic factory, the urea cycle, just for the waste product of one type of molecule. It really underlines how unique amino acids are compared to fats and carbs. They just skip this whole industrial level cleanup.
It absolutely does. The fact this specialized high-cost cycle even exists just shows how serious the nitrogen problem is. This mandatory detox is basically the first rule of amino acid metabolism. Cleanup required.
Okay, so nitrogen dictates the cleanup. Got it. But amino acids have a second, equally weird rule, right? Something about storage, or rather the lack of it.
Yeah, and this is where the difference becomes super clear, especially when you compare them to the fuels you're probably more familiar with. You almost think, given how energy intensive the urea cycle is, the body would want to save the raw material, the amino acids, right? Keep them handy.
Exactly. Like, think about glucose. Big pasta dinner, right? Extra glucose, straight into storage, glycogen, muscles, liver. Ready to go when you need it fast.
Yep, efficient storage. And fat. Even easier. Excess fatty acids get packed up into tags triglycerides. That's our best, most dense energy storage. The body has these really elegant, large-scale ways to save energy for later.
But the core finding in our source material about amino acids, it's really stark, points to a major limitation.
It is. Get this. There is not a designated mechanism to store excess amino acids in the body. Period. The body just doesn't have an amino acid version of a glycogen shed or a fat vault.
Wow. Okay, that totally fits the script on how we might think about protein. If you can't save them up, they've got to be dealt with, like right now. Used or processed immediately. It sort of implies protein intake is always this continuous moment-to-moment metabolic decision, not a strategic deposit.
That's the crucial takeaway for you, the listener. Because there's no storage buffer, any amino acids coming in have to be diverted immediately. They can't just hang around. Creates this real pressure for rapid use. So, okay, what are the two main places amino acids go right after absorption?
Well, the main reason we eat protein, I guess, is structural, building things.
That's use number one, and it accounts for, the vast majority. Amino acids are used right away to synthesize cellular proteins. Our body's constantly rebuilding, making enzymes, replacing bits, repairing tissues. That's the top priority. Structural stuff.